Hi, 8th grade. Welcome to lesson 8.2, find volume of cylinders. By the end of the lesson, I want you to be able to say, I can use what I know about finding volumes of rectangular prisms to find the volume of a cylinder. Let's explain it. Jenna and Ricardo are buying a new fish tank for the growing population of zebrafish in their science lab. Jenna says that the tanks hold the same amount of water because they have the same dimensions. Ricardo says that he can fill the bottom of the rectangular tank with more cubes so it can hold more water. Look for relationships. How are the shapes of the two fish tanks alike? How are they different? And who do you think is correct, Ricardo or Jenna? Explain. All right, I'll look for some participation and then we'll go over it together. Okay, similarities is their height, and in the cylinder, the diameter is equal to the side length of the prism. What are their differences? Is the base shape. Cylinder has a circle and the prism has a square. So who do you think is correct, Ricardo or Jenna? Remember that Jenna says that they hold the same amount of water and Ricardo says no, that the rectangular cube can hold more water. Ricardo is right. Because it can hold more water. All right, focus on math practices. How can you use what you know about the areas of two-dimensional figures and volumes of prisms to compare the volumes of fish tanks? So you should know that the volume of a two-dimensional figure area of two-dimensional figure and volume of two-dimensional figure are related. Volume is length times width times height. Well, isn't area of a rectangle length times width? So you're taking that length times width, which is the base, and you're also just multiplying the height to it. So that's the volume of a prism. But the volume of a cylinder is related. We just have to take the area of the base, and the base is a circle. So area of a circle, we should remember, is pi r squared. So to find the volume, we're going to take that pi r squared, and we're going to multiply it times the height. Just like we took the base of a rectangle as length times width, and multiplied it times the height. Example number 1. Relate volumes of rectangular prisms and cylinders. Jenna and Ricardo need to buy a fish tank that is large enough for 25 zebra fish. The tank needs to have a volume of 2,310 cubic inches. How can Jenna and Ricardo determine whether the cylindrical tank can hold the zebrafish? Remember, volume is the measure of the amount of space inside a solid figure. You can find the volume by filling the solid with unit cubes. Okay. So like you did to find the volume of the prism, fill the base of the cylinder with one layer of unit cubes and stack the layers to fill the cylinder. But you run into problems because you have parts of the cubes that are not totally full. So we're going to use that formula. Volume is big B times H. Now that big B stands for the area of the base, so it changes depending on your shape. Here we're using a circle, so we're going to use area as pi r squared times H. They tell us to use 3.14 for pi. Our radius is 12 because remember, if this whole thing is 24, the radius is half of it, so that's 12. So you plug 12 in for the radius, and the height is how tall the cylinder is 48. Okay, then we're going to work to solve, and you get 21,703.68. So it is large enough because we only needed 2,000. So it's much, much larger. Let's try it. The area of the base of the cylinder is 78.5 inches squared. What is the volume of the cylinder? So they already told us the area of the base is 78.5 inches squared. So we can just put that in for big B. And then we have to multiply it times the height, which is 11. So when we multiply that, it's going to give us 7. I think 830.5. So the volume of the cylinder is 830.5 cubic inches. All right, what can you use? Why can you use the formula V equals B times H to find the area of the cylinder? Because big B stands for pi r squared H, and that is the formula. Think about it. It's like if this is a cylinder, the cylinder is just filled up with however many circles fit into the height. That's why you take the area of the circle times however many of them can fit into it. Example number 2. Find the unknown measure. The volume of an apple juice can is 300 milliliters, which is equal to 300 cubic centimeters. What is the radius of the can? Use 3.14 for pi and round your answer to the nearest tenth. So we've got volume equals big B times H, but remember big B is the area of the circle, so pi r squared times H. Our problem is we don't know what the radius is. We're trying to find that. So we're going to work backwards. We're going to plug in everything we know. We know that this is 300 cubic centimeters. We know that we want to use 3.14 for pi. We don't know r, so we don't know what r squared is, but we know that the height is 14. So what we can do is multiply 3.14 times 14. So bring down the 300. 3.14 times 14 is 43.96, and we've got our r squared. I'm trying to solve for r, so the first thing I have to get rid of is this 43.96. It's attached to the r by multiplication, so we're going to divide. So it cancels out on the right, and we get r squared is equal to 6.82. And the last step, squaring. To get rid of a square, all you have to do is take the square root. Remember, there's that square root button on your calculator. So you get the radius is about 2.6 centimeters. Example 3. Solve problems involving the volume of the cylinder. Safety barrels are used on some highways to cushion cars on impact. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3.14 for pi. So we need to find the volume of each safety barrel. So again, we're using this formula, pi r squared H. They're putting the radius in, which is 0.45. They got that from over here because if the diameter is 0.9, we cut that in half to get 0.45 to be the radius, and we know the height is 1.2. So the volume of one barrel is 0.76302. So we want to figure out how many barrels we can fill. Well, we have 15 cubic meters of sand. So if we take 15 and divide by the volume of each one, we're going to see that we can fill 19.7 barrels. So can we fill a total of 20? No, you can only fill 19 and have some left over. Let's try it. Lynn is building a cylindrical planter with a base diameter of 15 inches. I automatically see that the diameter is 15, so I know I have to cut that in half to know that my radius is 7.5. She has 500 cubic meters of soil to fill her planter. What is the height of the largest planter Lynn can build? Use 3.14 for pi and round to the nearest inch. So we don't know the height, but let's remember our formula for volume is volume equals pi r squared H, and we'll fill what we do have. We know the volume is 5,000 cubic inches. They want us to use 3.14 for pi. times my radius. Oh, I don't want to put r. I actually know what my radius is. Times 7.5 squared times height. Now, height is what I don't know. Height is what I want to find out. So I'm going to use PEMDAS first. So I'm going to rewrite my 5,000 equals 3.14. And now I have to do 7.5 squared. And that gives us 56.25 times h. Now I'm going to multiply 3.14 times 56.25. And that gives me 176.625 times h is equal to 5,000. I want to solve for h, so I need to get rid of this 176.625. It's being multiplied, so I'm going to divide both sides by 176.625. So it cancels out on the right, and h equals 28.3085, keeps going. It says round to the nearest inch. So that would be, the height is 28 inches. Key concept. The formula for volume of a cylinder is the same as the formula for volume of a prism. The formula for volume of a cylinder is V equals big B times H, where big B is the area of the circular base and H is the height of the cylinder. So the volume of a cylinder is pi r squared, which is the base, times the height. Okay, 8th grade, let's say it. I can use what I know about finding volumes of regular prisms to find the volume of a cylinder. Have a great day.